So when we talk about API security, we're usually obsessed with who can get in, right? We focus on authentication, on keys, on who gets through the front door. But what if the real danger, the one that's truly devastating, isn't about getting in? What if it's about what you can do once you're already inside? Today, we're pulling back the curtain on a critical threat that hides in plain sight, deep inside your API's data. Check out this number, 885 million. That's not just some random statistic. That is the number of sensitive records. We're talking social security numbers, bank statements, the whole 9 yards, that were exposed in one massive breach at a financial company. And you know what the root cause was? A single, subtle API vulnerability that let it leak way, way more data than it was ever supposed to. So what's the common thread here? What connects that massive breach, a major security flaw at GitHub, and so many others? Well, it's a single, often misunderstood vulnerability, one that doesn't target the endpoint itself, but the very properties of the data your API is handling. Okay, let's dive into this. Well, it has a name. It's called Broken Object Property Level Authorization, or BOPLA for short. And there's a very good reason it's sitting at number 3 on the 2023 OWASP API Security Top 10. It is an insidious flaw that cleverly combines two older, well-known problems into one seriously dangerous vulnerability. You know, there's a great way to think about this. If you've heard of its cousin, BOLA, that's all about checking the key at the front door, making sure the right person is accessing the right house. BOPLA? That's about what happens once someone's inside. It's about making sure that just because you're in the living room, it doesn't mean you can waltz into the master bedroom, crack open the safe, and start messing with the property deed. Okay, to really get what makes BOPLA so sneaky, you have to understand it's not just one thing. It's actually a combination of two different security gaps that, when they come together, create the perfect storm for attackers. So let's break down what those two core flaws are. So on one hand, you've got excessive data exposure. Think of this as your API just talking way too much, leaking sensitive data out to the user. And on the other hand, we have mass assignment. This is where your API is, well, it's a little too trusting, letting malicious data get forced into your system. Let's take a closer look at each one. Excessive data exposure, man, this one is such a classic mistake. What happens is the server just sends the entire data object, packed with internal fields, sensitive info, you name it, back to the user. And you can almost hear the developers thinking, it's fine, the mobile app will just hide that extra data. But here's the thing, attackers aren't using your app. They're hitting the API directly, and they can see everything. All right, so mass assignment is the other side of that coin. A lot of modern frameworks, they try to be helpful. They have this feature that just automatically takes whatever data you send it and maps it to your internal database objects. Super convenient, right? But without super strict rules, an attacker can just slip in an extra field in their request, something like, is admin true? And the framework might just blindly trust it and write it to the database. Okay, so that's the theory. But what does this actually look like when a hacker gets their hands on it? Let's walk through how an attacker can turn these flaws into a full-on security breach. So let's start with excessive data exposure. Take a look at this. A user asks for their own profile. Totally normal, right? But look at what the API sends back. It's not just the name and email. Oh no. We're seeing stuff like an internal account risk score, different admin flags, and even internal notes. I mean, suspected structuring activity? That is pure gold for an attacker. Okay, now for the other half, mass assignment. So here's what a totally normal, everyday request looks like. A user is just updating their name and their bio. The API is built for this, it expects this, everything looks perfectly fine so far, or so it seems. But this is the attack. The attacker sends pretty much the same request, but they've snuck in one tiny extra line. Is admin true? Because the backend is just automatically binding data without checking a list of allowed properties, it takes this new field and just accepts it. It updates the user object, and boom. Just like that, with one extra line of JSON, this regular user is now a full-blown administrator. And look, don't think for a second this is just some made-up example for a video. Way back in 2012, this exact kind of mass assignment flaw fit GitHub. A researcher found they could basically upload their public SSH key to any organization, effectively making themselves an admin on any private code repository they wanted. The point is, the stakes are incredibly high. All right, so that's pretty scary. The obvious question is, how do we stop this? And the answer isn't just one magic fix. It's about building a solid, multi-layered defense that gets to the root of the problem at every single stage of your application. Your whole strategy really needs to stand on 4 main pillars. First, you got to design everything with the principle of least privilege in mind, right down to the individual data properties. Second, and this one is huge, you need to implement explicit allow listing for all your data. Third, keep an eye on things, validate and monitor your API traffic. And fourth, you have to automate this stuff. Put security testing right into your development pipeline. Okay, let's double-click on that allow listing part, because honestly, it is the most important technical thing you can do. You have to think of it as a two-way street. For data coming in from a request, you need a strict list of exactly which properties your user is allowed to change, and you reject everything else. And for data going out in a response, you need another strict list of which properties that user is allowed to see, and you filter out everything else. Seriously, never, ever trust the client to hide data for you. Ever. Okay, so where do you start? What can you do, like, today? If you're a developer or you own a security team, here's your action plan broken down by what you need to tackle first. All right, priority number 1, critical. Do this now. First, lock down any API endpoint that takes in data. Put that allow list in place to stop mass assignment cold. And at the exact same time, you need to go on a hunt through all your API responses. Find every single piece of sensitive or internal data that's leaking out and get rid of it. Just doing those 2 things will wipe out the vast majority of your BOPLA risk. And that really brings us back to where we started, with a question you really need to ask yourself about your own applications. Is your API just checking the key to the front door, or is it actually securing every single room, every drawer, every file inside that digital house? Because in today's world of API security, that's the only question that really matters.